So, good day, and today, as per my promise, I will take up a few representative questions to initiate you into the problem solving. The first question, which appears here on your screen, I read it for you. A truck of mass 7,500 kilogram starts from rest and rolling down the hill on an inclined road of constant slope, travels a distance of 400 meters in 20 seconds, finds its acceleration and calculate the force acting on it. So, after reading the question, as I told you, we will say the question in our own words, make a schematic diagram, okay? And so, to solve this question, I'll just have the road, which is something like this, and on this road, which is of course a rigid body is defined as the one which we think that it's not going to move, it's not going to be disturbed. And then I have the truck. I just make a representative truck, okay, just like that. My truck is there, and at time t is equal to 0, the velocity of the truck is 0. That means we can say that the initial velocity is equal to 0 meter per second. The mass of the truck will just write here. This is the data, kilogram, okay? And then suppose this happens at time t1 is equal to 0, and after some time my truck reaches this point, and this point is, for the truck, is 400 meters away. So I'll just make it 400 meters away, and the truck stops. I'm sorry, it doesn't stop. It acquires a certain velocity, v meters per second. In the meantime, it is accelerated down the hill. So I'll say that there is an acceleration and which we have to calculate, so therefore I just put the interrogation sign over here to do it. And this time I will also write like t is equal to t2 is equal to, say, how many seconds? Look at the problem. In 20 seconds, t2 is equal to 20 minus 0, yani t2 minus t1. This is delta t, and this turns out to be equal to 20 seconds. So I make a connotation, and I understand what I have done, and then we look out as to how we are going to have the solution. For the solution, let us see the equations of motion in constant acceleration. This is taken as a constant acceleration. So for constant acceleration, we have a set of three equations. V is equal to u plus at, the first equation. S, the distance, is equal to ut plus half at square plus half at square, and v square is equal to u square plus 2as. So these equations we write here, we learn them by rote, and then we see as to what we have to apply and how and which formula has to be chosen. So here the distance of travel is given, the time is known to us, and we have to find out what is the value of the acceleration. So naturally our choice goes to this equation. So we write s is equal to ut plus half at square, substitute the values, half at square, and this because u is equal to 0, initial velocity has been taken as 0, so the first term becomes equal to 0 plus half at square plus half at square, and here I have a distance of 400 meters as per the data that are available to us. So therefore my acceleration will become equal to, I can write 2 into 400 divided by 20 square, which is again 400. So this turns out to be equal to 2 meter per second square. Simple calculation. Now the mass factor was not at all relevant till we find the value of A, and the mass factor becomes relevant in calculating the force. So the force, according to Newton's second law, we recall that this is equal to m into A, and the mass is given 7500 multiplied by A, which is 2 meter per second square. Okay, so this turns out to be 15,000 okay, newtons, which in the scientific connotation we must write as equal to 1.5 into 10 to the power of 4 Newton. Now, if in this question, in addition to whatever has been asked, if we ask you as to what is the velocity, okay, then in case the velocity has to be calculated, then we go to equation number 3. V square is equal to u square plus 2as, and from there we find that the v square is equal to 0 plus 2 into whatever, and then take the under root and find the velocity, which will turn out to be equal to, please calculate, 40 meter per second. Okay, so this is your question number 1, and now we go to question number 2. Taking the second representative question, which appears there, I can read it for you. It says 2 blocks made of different metals oblique alloys but identical in shape and size are acted upon by equal forces so that they slide on a horizontal surface. The acceleration of the second block is 5 times that of the first one. Calculate the ratio of their masses. Okay, so now I will say this question in my own words and make some sketches. So the first thing is that our surface on which the block is put, that surface is, this is, I've just taken it as a box type thing with a certain shape and size, to which I apply the force F. Okay. Now this block may have a volume V, and it may be made of a density of, say, rho 1 kilogram kg per meter cube. Okay, this volume is also in meter cube. Okay, so I can therefore say that the mass of this block M1, mass of the block M1 is equal to V into rho 1. Okay, kilogram. Now I can draw here itself the other block of the same size, and of course the mass will be different, of the same volume, and there also we apply the same force F. So the forces in both the cases are the same, F, and this has got a mass, say M2 is equal to V into rho 2. Okay, so M2 kilograms. This is not necessary. I have just told you that there is something called the density because the blocks have been made of different metals or alloys. Okay, so they have naturally, and we take this case where there is no friction, etc. Okay, a smooth plane on which the two blocks are kept, and so I can write my equations that the force on the first one is equal to its mass m1 multiplied by the acceleration which we obtain, and this gives us the value of acceleration a1 is equal to F upon m1. Okay, and similarly I can write the other equation. It's very simple. F is equal to m2 into a2, which gives again the same way that this a2 is equal to F upon m2. So these are the two equations. So now if I divide this equation by this equation, left hand side to left hand side, right hand side to right hand side, I get a2 upon a1, which is given to us. This is equal to 5:1, 5 times, and this is equal to, I will write the whole thing, F upon m2 divided by F upon m1. And now in our junior classes, we remember the case of proportions, that this will become equal to F multiplied by m1 divided by this m2 into f. So the f and f, they cancel out here, and we are left m1 upon m2. So m1 upon m2. So readily we can find out that the ratio of the two masses, if I calculate the m2 upon m1, naturally this will turn out to be equal to m2 upon m1 will be a1 upon a2, and that is 1 upon 5, 1 upon 5 or 5 inverse, and this is equal to 0.20, and this is how we have been able to obtain the ratio. Okay, this kind of a question can also be expanded, and you can be asked to tell what is the ratio of the density of the second to density of the first. Just instead of m1 and m2, we can write v into rho 1 divided by v into rho 2, etc., etc., and obtain the results. Now we go to question number 3. Now question number 3, a relatively very simple question appearing on your screen, and I read it out for you. A body of mass 2 kg is moving with the velocity of 20 meter per second. A force is applied to the body for 25 seconds so that the body attains a velocity of 40 meters per second. Calculate the applied force. It's a very simple question. The answer to this question is also quite simple, and I have taken it as a representative question. So let me make a picture of the body. The body, again I take a box type body, and maybe I say that this is again on a smooth plane, horizontal plane. The mass of this body is 2 kg, 2 kilogram, and a force is applied for a certain duration. The force is F, and the duration delta t, time delta t for which it is applied, is equal to 25 seconds. To 25 seconds. Now the initial velocity u is stated to be u is equal to 20 meter per second, 20 meter per second, and v is also given to us, and v is equal to 40 meters per second, 40 meters per second. The time is also given to us, that t is equal to how much? Applied for 25 seconds. 25 seconds. So readily the formula that comes to our mind is that we must have the formula v is equal to u plus at, which helps us to calculate the value of the acceleration. And if I substitute these values in here, 40 is equal to 20 plus a into 25. Look here, I am not writing the units, so I am avoiding that part for quick calculation. It turns out to be equal to that a will be equal to 20 divided by 25, okay, 20 goes on the other side, and A will become equal to 20 divided by 25 meter per second square. Meter per second square. Now they want the force. I have not solved it. The force is equal to F is equal to MA is the other formula that we have to use, and M is known to us. So this will be equal to 2 into 20 upon 25. So calculations will make finally is that will be 40 upon 25. This is equal to 40 upon 25, and to calculate it quickly, multiply 25 by 4 and this also by 4. So this will become equal to 160 quickly divided by 100, which is easily 1.6 newtons. Khalas, finished. So very easy question and very easily solved with the help of the kinematical equation and also with the help of the dynamical equation. This is F is equal to MA. Next question we take. Question number 4 is appearing on here on your screen, which I read for you. A bullet of mass 40 kilograms moving with a speed of 90 meter per second hits and enters a heavy wooden block and is stopped after a distance of 60 centimeters. It goes inside the wooden block and is stopped after it pierces. What is the average resistive force? What is the average resistive force exerted by the wooden block on the bullet? So this is the question, and now let us say the question in our own way. The bullet hits a wooden block. Okay, so I just make the bullet and it hits the block with an initial velocity of 90 meters per second. The mass of the bullet is M is equal to 40 gram, which readily I make it as in kilograms. 40 divided by 1000 kilogram is equal to 0.04 kilogram. Easy. Now it enters into the wooden plank, goes to a distance of 60 centimeters, and then it stops. Naturally, there is a average retardation, and we get the this is S. Okay, this velocity is U. Okay, and final velocity is V, which is equal to 0. So let us choose. We have to calculate the value of A. Acceleration is equal to what? So which equation we are going to choose from kinematics? The equation is, okay, S is equal to, S is given to us, so that has to be used. So S is equal to ut plus not this S equation. Recall, that the time is not given to us, so we cannot use this equation. Instead we have to use the equation v square is equal to u square. U is also given, plus 2a, which I have to determine, a into s, which is x minus x naught, whatever you want to say. So v square is equal to u square plus 2as. V is substituting, v is equal to 0 and u is equal to 90 meter per second. So 90 square plus 2a, and this is actually 60 centimeters is equal to 0.6 meters. 2as, so here I multiply it by 0.6. Look here, this I multiply with this kind of an asterisk sign purposely, because otherwise I don't take this this or this or this, all these things, the cross, the cot, the dot, etc., and I write like that, which gives us the value of a. I can write as minus 90 into 90 upon 1.2, together 1.2, and which we calculate. When we calculate this out, this turns out to be 2279. I'm sorry, not this one. I leave it here, and because the mass of the bullet is given to us, therefore the force we have to calculate, the force of retardation, is equal to ma, just the magnitude of it. The direction of the force, we always know that it's opposite to the direction of the bullet, and ma, and therefore this is equal to, I'll just take the magnitude of a, and this will turn out to be equal to 0.04. Now we don't write minus etc. here, into 90 into 90. I'll write just like that. I suggest that 1.2, and I multiply it by 10 here, and 10 I take from here, so this becomes equal to 4 upon into 9 into 9, which is 81, divided by 1.2, and when we make out the calculations, okay, this is 270 newtons. 270 newtons. So that is about the question before. Now the last question for today we are taking up, and it's appearing on this side of your screen. I read it for you slowly. A rocket of initial mass 5,000 kilogram ejects gases or gaseous mass at a constant rate of 15 kilogram per second with constant relative speed of 10 kilometers per second. What is the acceleration of the rocket 100 seconds after the blast? Neglect gravity and use A is equal to small m small v upon mi minus mt. So we make up our own data sheet for that. First of all, we have A is equal to the acceleration is, I don't suggest that you remember this formula. but it's only an exercise, a numerical exercise. A is equal to mv, the formula is given, but if you do a couple of questions or some more, then you might even remember as to what is this. The acceleration is equal to this minus mt. The acceleration is equal to this into mt. Now m, I, here I have, I am given as 5,000 kilograms, 5,000 kilograms, a massy thing, that's the rocket, and the gaseous discharge m is given as 15 kilograms. Remember, this is not mass, but mass emitted out, ejected out per second. And so the time that it takes is equal to 100 seconds when we have to calculate the acceleration, associated acceleration, okay, and the velocity is the velocity with which it is being ejected is 10 kilometers per second. 10 kilometers per second, which will readily convert into meters per second. So this is 10,000 meter per second. With this data, when I feed in the equation, so this certain equation over here, so I will get, this is equal to 15 kilogram per second. 15 into V, which is 10,000 meter per second. So divided by 5,000 minus 15 kilogram per second, 15 and into 100. So it turns out to be equal to 15 into 10 to the power of 4, and here it is 3500. So we can cancel this with two of them, and when we work out, this turns out to be finally, this is equal to around 42.9 or 42.9, which is meter per second square. Meter per second square. So this is it. Now friends, what we propose is that the PDF file of all these answers and the questions will appear in the comment section of associated with the lecture, and you can download that and take help of those comment section to ask questions which you encounter and you are unable to arrive at the result which is you think that you are confused. So try to ask those questions, because one of the things that shows that you know something is the state of confusion that you have, and which is the purpose of my lectures, that UQVA, UQVA, even VQUA stage may also come. Thank you very much for the day. And the next item that we take up is something empirical. Empirically determined things which are very, very useful, and the whole idea is very, very interesting as to how to deal with friction. First of all, friction with surfaces in the linear system, and then rotational friction, etc. That we'll do in 3-4 lectures from now. Okay, taking some examples and interesting examples to make you understand those that information which will be useful to you. So thank you very much for the day. See you soon.